Today we're going to go over 6-4 rational exponents. We're breaking this up into 2 separate days. But really what we're doing is we're going to be converting both radicals into exponents and exponents back into radicals. Okay. So, first thing I want to go over. Alright, so if we're looking at a radical, we have our radicand underneath the radical sign and then we have our index right here. Okay. We're going to use that index to help us convert this into an exponent. Okay? So my variable x stays the same, or that's going to be the base. So this is the base. So this is the base. And we're going to take what this is raised to. So if x is the radicand right here, what is it raised to right now? What power?
1.
It's raised to the first power, right? So that's going to go on top. What goes on bottom
3.
is going to be the index, which is 3. So let's try another example with x being raised to a different power. So say I have x raised to the third power and my index is 4.
3/4.
So that's going to equal x, and I'm going to use x is raised to the third power and my index is 4. So x is raised to the 3/4 power.
Yep.
Okay. Does anyone have any questions on that? So these are the basic properties that we've already actually gone over with our exponent rules when we were reviewing them at the beginning of the year, the first week of school. We talked about these properties. A raised to the n power times a raised to the n power, we can add those exponents together. We're going to be doing some of these same things. Yes, sir.
Amanda Frank.
Right there. Okay, so moving on. So you can review these notes and have these notes in front of you for when you're working on the practices. But we're just going to kind of skip over a part of it. We're going to go down to this key concept with rational exponents here. So if the 9th root of a is a real number, m is an integer, and m over n is in lowest terms, then a over, I gotta zoom in here. So pretty much what we can do is we can interchange these out. Really what we're saying is we can convert an exponent into a radical and a radical back into an exponent. So these are interchangeable, it doesn't matter what way you write them, it means the same thing. That's all what this key concept is really saying. Okay? Alright, so we're going to flip over and look at problem number 1. So we're simplifying expressions with rational exponents. Okay. So what we want to do is we're going to convert these into radicals. So we're going to convert 2/16 to the 1/3 power into a radical. So how can I write that as a radical expression?
216 inside the radical, 3 outside.
Okay, so 3 is my index, and 2/16 is raised to the what power? First power. So this is just the cubed root of 2/16. Now how can I break up 2/16? Anybody know? We can do 6 times 6 times 6 equals 2/16. And that's, so I have my group of 3, my index is 3, and that's what I'm looking for, my group of 3. So you can pull that out. and my answer is 6. Now we could have broken down those 6's even further. We could have broken them down 2 times 3, 2 times 3, 2 times 3. And you're more than willing or welcome to do that. Then you would pull a 2 and a 3 out, and you're actually adding more work to yourself because you're putting those back together. So as long as you have a group of 3, you can pull those out. Okay. All right. So let's try another one. We have 7 raised to the 1/2 power times 7 raised to the 1/2 power. What's another way, or now, what exponent rule can I use here? We're multiplying two numbers with the same base together, right? So we can add our exponents together. So we have 1/2 plus 1/2. Now when I'm adding fractions, I'm going to add across, but do my denominators change at all? No, it's going to stay 2. Then we're just adding the top.
Can I ask you a question?
Yes, sir.
If I wanted to just put this to like square root of 7 times the square root of 7, and I get a square root of 49.
Yeah, I was going to do it both ways.
Oh, okay.
Yeah. So this is 7, or what's 2 over 2? What's a way to simplify that? Yep, that's equal to 1, so we have 7 to the first power. Okay. Another way of doing this is to rewrite it like D'Angelo was saying. 7 raised to the 1/2 power is like saying the square root of 7 times the square root of 7. Well, we can put that under one umbrella, one radical sign, and say 7 times 7, and there's my group of 2, and pull it out, and I still get the same answer. See, these are interchangeable. Whatever way you'd like to do it, it's the same answer. Okay, so let's move on to the next one. So I have 5 raised to the 1/4 power times 125 raised to the 1/4 power. How can I rewrite this? What's my index? 4, right? So I have my index 4 with the radical sign 5 times the index of 4, 120. Now I want to put these all under the same roof. I want to put these all under the same radical sign. Because I got to find a group of 4, and I don't have a group of 4 yet.
5.
Alright, so how can I break up 125?
3 5s.
3 5s. 5 times 5 times 5. So this index tells me what I'm trying to find groups of. I'm trying to find a group of 4. 1, 2, 3, 4. Alright. And I can pull that out. So my answer should be 5. What questions do you have so far? We're good? Alright, so I want you guys to try out A, B, and C. I'll give you some time to work on those, and then we'll go over them as a class. A few minutes to work on them. Oh. Okay, for A, we have 64 raised to the 1/2 power. How can I write that as radical? we just do the square root of 64, right? Because my index is 2. And 64 is being raised to the first power. So, how can I break up 64? Okay, I can break it up into 8 times 8. And my index tells me what I'm trying to find a group of. I'm trying to find a group of 2. And I can pull that out, and that's 8. Alright, for the next one, we can do this 2 different ways. We can either add our exponents, or we can turn these into radicals. Let's do both ways. Alright, so we have 11 to the 1/2, and we can add our exponents together because they're the same base. So we have 11 to the 1/2 plus 1/2, that's 11 to the 2/2, which is equal to 11 to the first power, or just 11. The other way to do that would be to convert these into radicals. We got 11 times the square root of, or the square root of 11 times the square root of 11. Put those underneath the same umbrella. My index is 2, so pull out. We get 11. Alright. And for the last one, we have the square root of 3. After I convert the 3 to the 1/2 power, it's the square root of 3 times the square root of 12.
Take the 12 down.
Yeah, we need to break that 12 down. We're going to put this all underneath the same radical sign.
We got 3 already.
We got 3 already, and we're going to break down
3 and
12 into 3.
Then 2 and 2.
Yep, and then 3 times 4 is 12, but we can break out 4 into 2 times 2. Good.
You got 2 groups. And 6.
There's my 2 groups. We bring out the 3, we bring out the 2. So we got 3 times 2, which is 6.
Yep.
Okay. So, part of your homework today is going to be 10 through 18. Okay, we're going to move on to problem 2 though on the next page. So, these problems are going to be exactly like problem 1 up here. So they're categorized under the same. Okay. Okay. Problem 2 is converting between exponential and radical forms. Alright, so now we're dealing with indexes that are going to be a little bit, or we're going to be raising these variables to different powers in different indexes, okay? So we're just throwing a little bit, we're building on to what we've already learned. So if I wanted to write x to the 3/7 in radical form, x would be my radicand, but what would x be raised to? It'd be raised to the 3rd power. And what would my index be then?
7.
7. Now, y is a little bit different, or when we're dealing with the y term, that's a little bit different. How can I convert negative 3.5 into a fraction?
On your calculator.
You can use it and do that on your calculator, yeah? So, not all of you have them right now, but if you wanted to, you can use, a little bit unsure as to how to do this exactly.
You put negative 3.5, and then you hit menu,
Menu,
and you hit 2,
number,
and then you hit 2 again. And then,
approximate to fraction.
and then you hit enter.
Okay, good. So, that's awesome, Angela. Thank you. Alright, so we have negative 3.5 if you hit menu, number, approximate the fraction, it's going to approximate that to negative 7/2. Okay, so now we can use that. So we have y raised to the negative 7/2. Over here.
And what are the steps for the calculator? Menu, then.
Menu, number, approximate to fraction. So it's menu 2, 2. might wanna write that down. So you hit menu, 2, 2, so approximate the fraction. Okay? So now that we have y equals negative 7/2, how can I rewrite this to get, I can't have a negative
2 square root y.
in my exponent. So how can I convert this so it does not have
2i.
a negative?
2i squared.
Flip it.
You have to flip it, you have to put it on the bottom, right? So to get rid of a negative exponent, you put it on the bottom. So this is equal to, so we have y to negative 7/2. That's equal to writing 1 over y to the 7/2.
Wait, what? What?
We can't have a negative exponent, so what we're doing is we're getting rid of the negative exponent, so we can convert this radical form. Okay, when we have a negative exponent, in order to get rid of it, you move it to the bottom. Okay, now what we can do is we can take that radical form, and we can have, it's the square root of y to the 7th power.
You go over.
Oh, sorry.
Isn't the answer?
That's where she left it. If we might want to convert this by multiplying the top and the bottom by the square root of y to the 7th power. Because we can't leave this, or the simplest radical form wouldn't have that. And we'd have the square root of y to the 7th over
Y7.
y to the 7th.
What was the X answer? I didn't see that.
They were playing this music yesterday during the test.
Right there.
I was just like, can I see the other final answer?
We'll zoom in a little bit.
So,
We multiplied the top and the bottom by the square root of y to the 7th. That would change that to y to the 7th on bottom, and then 1 times y to the square root of y to the 7th.
Can you zoom in on the answer?
Yeah.
Alright, that's good, thanks. Alright.
Okay. So I want you guys to try these two right here. You might need to grab a calculator to convert this to convert 0.2
it's 2/10.
or 2. Yeah, it's 2/10 or 1/5.
Thank you.
How do you do it when there's parentheses outside of it again, like for B? How do you do that one?
Oh, well, I just want you to try the A right now, and we'll do B together.
Oh, okay.
Okay. So yeah, just try out A right now.
Does that say 5 over 8?
Yeah, it's negative 5 over 8.
Oh.
I know, it's not really clear.
Wait, negative.
Congrats, Josh. I'll vote for you.
I voted for Josh. Josh didn't get it.
Is he sick? Yeah, he's sick. Yeah, he's with me.
No, I'm talking about like.
Oh.
Okay, so how do I get rid of this negative fraction? What do I have to do to it?
Put it on the bottom.
Put it on the bottom, right? So we have negative, or w to the negative 5/8, and we're gonna move that to the bottom. Okay, so it's 1 over w to the 5/8. Now I need to convert this into radical form. So that's 1 over, and then my index is gonna be 8w to the 5th.
That would be 5. Okay.
My index is 8. And w is raised to the 5th. And if I wanted to take this even further, I think she's okay with you leaving it like this for these type of problems, but if you want to take this further, you're going to multiply the top and the bottom by the 8th root of w to the 5th power and got n.
Can I ask you a question?
Yes, sir.
We don't need to combine like terms for like. So okay, so you see how you have w to the negative 5/8. If I
Right.
convert the w 0.2 to a fraction, you get w1 to the 5th. I don't have to combine those two, do I?
No. These are two separate problems.
Yeah,
Yeah, these are two separate problems. Yeah.
Yeah, that's what I was making sure.
Alright, so the next one, w to the 0.2 can be converted to, like somebody else said, w the 2/10, which is reduced to w to the 1/5. So all I need to do is take the 5th root of w.
Love this song.
I have a pass to leave. Can I go?
Oh, yeah. Alright, so we just have a couple more examples and then you guys can get started on your homework. Hopefully you'll have some time. We're working backwards now. We're converting radicals into exponents. So you gotta think of what's my index for this first one. My index is 2. So my base is going to be a. The base is always going to be that radicand, and then the top number is what it's raised to. The bottom number is the index.
5/2.
Yep. And for the second one, what we could do first, this might be a little bit easier if we convert this into a exponent first, and then we'll carry this over. So how can I rewrite what's inside as an exponent?
B to the 1/5.
B to the 1/5, right? And that's being raised to the 3rd power. So what do I do with that 3rd power? We're gonna multiply what's on the exponent on the inside. So it's b to the 1/5 times 3, which is b to the 3/5.
How can you do that if the denominator's not the same?
When you're multiplying, you can multiply across, and the denominators do not have to be the same. But when you're adding, you do need to have common denominators. Okay, so just try these last two out on your own, and then we will move on to the homework. Okay.
Is there another way to do that for B?
Nope.
Or is that the only way?
For this one,
Yeah, is that the only way to get B to the 3/5?
no, I guess you could just raise the b to the third power and make it 3/5. But because this is afterwards, it makes more sense for me to convert this first and multiply that. But if you just add b to the third power, it end up being the same answer, right?
So what's our homework? Is it all the way up, the rest of the problems on this page too?
Yeah.
So 10 through 18, then 19 through 34. You guys think? You guys think?
Just remember those ones.
Really cool.
Okay, so what's the first one? My base is x,
3/4.
so 3/4, and the second one is y to the 4/5. Okay, good. So the rest of the time, take your time and
What is the number? The worst number, 1 over what?
it's 1/6.
Is it 6? Could tell if it's 5 or 6.
Yeah, it's 1/6. Okay. Travis, you can.
Yep.